Welcome back to the Electrical Building Design Show. Today I have Kevin Lawson from Ripple as our guest. He's here to talk to us about AI in the MEP industry and what he's doing on the HVAC side. So, Kevin, how about you introduce yourself? Let us know what you're doing and what you do.
Sure. Thanks for having me. My name's Kevin Lawson. I'm a registered professional engineer. I spent about 10 years designing, commissioning HVAC systems, plumbing systems on buildings. And about 4 years ago, I left the consulting world to start a software company, Ripple, and we are automating HVAC design. So what that means in practice is we have a Revit plugin. The goal is to use that Revit plugin, take the architectural Revit model, and automatically generate an HVAC model.
Very good.
So that's where I'm
Yeah.
at.
Yeah. And you're on the mechanical side.
That's right.
And one of the hobby horses I always beat on here is that electrical and mechanical are different. MEP always gets like lumped together.
Yes.
But we're going to see what we can learn from the mechanical side on the electrical side, because they are different and we need to talk about mechanical electrical differently. But there's also a lot that we actually do have in common.
Yeah,
which is
and
why
there's
we
a
get
lot of
lumped together.
coordination that has to happen, and that's one of the reasons I really started with HVAC. I feel like HVAC is a complicated system to design as opposed to, say, like plumbing, but HVAC is a blocker for almost every other trade. So you need the electrical loads in the model to do your electrical system. You need the equipment weights to do your structural design. The architect needs to know how big the mechanical rooms are. All that stuff is blocked by the HVAC system. So the quicker you can design the HVAC system, the smoother everything else goes. So anytime I get questions about any electrical tooling that I build, first of all, I send them your way. Second of all, I say, the best thing I could do for you is get the loads in the model quickly, and that's, and I honestly, I feel like that's a huge help for electrical engineers and electrical designers.
Yeah. There's obviously tons of coordination that has to happen between all disciplines. And so electrical and mechanical do need to talk to each other.
Yeah. HVAC is brutal on coordination though. Everything relies on HVAC. And it takes the longest to design. If you're never at the end of a project waiting on the plumbing engineer to finish up. He's been done for months. Well, HVAC's add in electric unit heaters at the end of the job. We're changing fan sizes.
Yeah. Well, today we want to talk about AI. When you say AI in building design, what are you thinking about with that?
So, and this is, AI gets kind of thrown around a lot. So if you define AI, the way I like to define AI is you have an input, you have AI, you have an output. If that output is human-like, I call that AI. So it doesn't really matter how you get there. If you're getting a human-like response, it's AI. So ChatGPT takes a human-written text question and it gives you a human-like response. So that's AI. You could say the same thing about like cruise control. You could call cruise control AI. Cruise control modulates the speed of a car just like a human would. And so is full self-driving. Full self-driving is just a more advanced form of AI. So what my software does is not like a big neural network. It's not like a large language model. It wasn't trained on data. It just follows the same procedure. And it's the same procedure any engineer would follow while they're designing an HVAC system. So it's not some complicated, trillion parameter model. It's just a series of if-then statements, just a couple 100,000 of them. But at the end of the day, what you get an input of an architectural model and you get an output of an HVAC system that looks like it was designed by a person. And so I call that AI, Maybe I'm trying to jump on the hype bandwagon, but that's all right.
Yeah. So that's what you've got going on the mechanical side. And you're able to automate the layout of the mechanical?
Yeah. So again, we just go in order of how a mechanical engineer do it. So we start with the load calculations. So back when I kind of was starting this, I actually did everything in AutoCAD. So then I jumped into Revit and started digging around the back end of the data available that's in Revit. And I realized everything's here: window sizes, window orientations, furniture, all the stuff that the mechanical engineer needs to kind of count and associate for loads is all in the model. So now it's just Now it's just a function of pulling that architectural data, running the calculations, and then selecting the equipment. So we start with load calculations, ventilation calculations, all the calculations necessary to select the equipment. Then we have integrations with manufacturers. And so we take that data, we pass that data up to the manufacturer selection software, and the manufacturer selection software says, okay, you need this equipment for these spaces. And then I could just drop those families into the Revit model and go from there. So it's all been about equipment selection up until this point. We're finishing up on duct layout and auto pipe layout to get everything connected together. And I hope to have that ready by the end of the year.
So going back to the first step, you said you have the model from the architect. Are
That's
those
right.
models good enough to use?
Yeah, they are. I mean,
I'm such a skeptic here.
yes. Okay. So the vast majority of them are good to use just as the architect designs them normally. So we did a big study with a big hospital group. They built a building, a medical office building back in 2020. And so they wanted to see, hey, are your load calculations accurate compared to the real building?
Yeah.
So they took their BMS data, building management system data from that building, and they calculated what the actual loads imposed on that building were. And then they gave me the Revit model, didn't tell me what the loads were, just gave me the Revit model and said, run loads and tell me what you think the loads are. So that architect that made that model was not planning on anybody running loads on it. They were not planning, it wasn't built in a specific way. I didn't get to have any say over how it was built. It was just how an architect normally built it. So they gave me that model. I was able to run loads, automated loads, so I had loads done in 6 hours as opposed to 2 or 3 weeks. And I returned them to them, and our load calculations were within 1%. So that's extremely accurate for a load calculation. So the existing equipment that they installed with that building was 100% too big. So they needed a 10-ton rooftop unit. They put in a 20-ton rooftop unit. And I think that's pretty standard for the industry, is about, 100% too big, I think, is what most engineers are doing.
Yeah. So you were able to take just an arbitrary Revit model.
Yeah.
And if the architect's doing a decent job at Revit, but like you said, not really thinking about the mechanical, you're still able to take what they give you.
Yeah. And it makes sense. I call it curated data. So what really matters in load calculations is windows. And so if the architect is not putting the windows in the model right, it's not getting displayed right. The plans aren't right. The schedule, so all that, the architect cares about all that stuff way more than the engineer does. If the engineer is a couple inches off, it's not that big of a deal. So the architect is curating all that data. They're getting the information in correctly.
Okay. And then like the rooms are laid out well enough to.
Yeah, I mean, the architects use rooms for their area calculations. So they're always using rooms. They're always naming the rooms so they could tag it. So all that data can then feed through into the mechanical system. So the rooms are the room name and area gives you a really good indication of what the internal loads in that space are going to be. So if they name it, RR, and it's 100 square feet, it's a private restroom. So, that's got exhaust requirements. You've got, and you could start applying all that data to it just based on the name. So that saves a ton of time.
So figuring out those names, how algorithmic is that? Is that any sort of like large language model figuring that out?
There's some special sauce in there, and it's based on, I think I had like 60,000 room names and areas to kind of train on, and I get pretty close. I'm into like some and 60,000 isn't too much. So this is when I was just getting started. I've got a lot more now, but I haven't gone back to improve anything. Because you start to get diminishing returns. If I could get 90% of the rooms accurately, I could go through and just assign the other space types. So there's a little bit of secret sauce in there, but it's not too, it's nothing like a ChatGPT or any other LLM.
Okay. So there's still some cleanup to be done.
Oh, absolutely. And that's kind of where we go back to why this is done procedurally and not like a big LLM that might hallucinate stuff. So as you go through, you can correct, so if they name it RR and my software interprets it as a restroom, but really it's a railway office or something, you can go back and say, okay, this is not a restroom. This is a office. And every step of the way, there's breakpoints where an engineer can review it. So space type assignment, load calculations, diffuser layouts, VAV selections, ventilation calculations, air handling equipment selections. All that stuff can be kind of mix and mash as you go through. And that also helps when it inevitably does something wrong. You only have to go back to that spot, you know.
Yeah. And then you're doing the duct layout also, or you're
Yeah, the
working
duct
on that.
layout is nothing that's been released yet, but
Okay.
it's I have an algorithm that is now connecting all of these ducts to the air handling unit, down to the VAVs, and then from the VAVs to the diffuser, and it is just absolutely amazing. I mean, it saves so much time, um, just with the layout, and the layout is a great time saver. But what really saves time is when you continue to enrich that data. So in addition to my automatic duct layout, I have assigned pressure drops to all of the fittings into the ducts. So now I get pressure loss calculations. So now I could feed that pressure loss calculations into the fan selection software and get a real motor size for that specific building instantaneously, which again feeds into your electrical system and
Yeah.
into your electrical one line.
Okay, so this is where I always struggle with what we're doing as an industry, because everything you're doing is amazing and super important and valuable. But it's not like this is even AI. This is just finishing BIM that we were promised 25 years ago when
That
Revit first came out.
that is absolutely right. I mean, it is. I mean, most of it is just getting the out of the box Revit set up to where it could be helpful. I mean, these pressure loss calculations, it's essentially a schedule. The cost estimates on the ductwork, it's just a schedule. It's just this data getting built in. But the automation does help because um, if you're manually laying this stuff out and you're not getting it, it takes so much time to get that last step to get it all connected up so the airflow propagates so you could do the pressure loss calculations. So people don't do that. So they don't focus on building the pressure loss into their fittings. So it's kind of like it's a snowball effect. You start doing, if you automate one thing, okay, now it makes sense to automate the next thing. And now I've got a really valuable, not just auto layout tool, but cost estimates. How many pounds of sheet metal do I have? What's the pressure loss? All of how much insulation do I need? All kinds of great stuff. Because the automation just keeps snowballing.
Yeah. I found with what we're doing, a lot of times, like those calculations are fairly straightforward. It's just all the data input to get to the point where you can even do a calculation.
Exactly. Yeah. Yeah. And I kind of struggled with that because a lot of times when you go to engineers or designers and you kind of say, okay, I'm thinking about automating this, like, would that save you time? And they always go, no, that wouldn't save me any time. And they go, okay, what about automating this? And they're like, oh, that only takes a couple minutes. I could do that really quick. And then you're like, well, what about this task? And then you get to the end and it's like, well, you must be like the most profitable, fastest growing engineer because nothing takes you any time. And they're like, oh no, we have terrible margins and and it's like, okay, well, what is actually taking you time? So I think it's hard, and this is all estimating in construction. It's hard to think of a job or a task and not think, oh, I could do that right away. But in reality, it always takes you longer than you expect. That's why construction estimating is such a tough field.
Yeah. So as you're looking at the other AI stuff that's coming out, what's your reaction when you're seeing these AI demos coming from other companies?
Um, I it's really hard to tell. It's really hard to tell without seeing an output of an actual design. So I'm an engineer. I can, I'm a critical engineer too. I can look at a HVAC design and tell you if it's good or bad. So I try to withhold judgment until I see an output. show me a design that an AI has done, and I'll, then I can tell you if it's good or not. So it makes me skeptical when I don't see an output. The other thing is, if it is AI, if it is automated, you should have no problem displaying it, to showing it. Give me a model, I'll run my automation tool, and I'll show you the PDFs. That shouldn't be. So the fact that you're unwilling to do that, or you want money for it or fee for it, is makes me pretty skeptical. And so I just try not to get tied up in it, because I just kind of have to focus on my own thing.
It feels like a lot of hype without actual. It feels like if it works, they should be able to show the proof of work,
and very quickly and for free. It should cost $20 of compute. And so why wouldn't you if it really works, why wouldn't you show everybody?
Yeah.
Is my thought, but I have no idea.
Yeah, I see a lot of them exporting out of Revit as well, which always is a red flag for me.
Yeah, I think that's done. And again, I don't really know, but I think my hunch is that if you want to raise like VC capital, no, I don't think any VC wants to fund somebody who's got the platform risk of being on Revit only, because Autodesk can do all different kinds of things. And that might, if Autodesk tomorrow said no more plugins, well, my business is dead, and so VC wouldn't want to fund that. And that's why I'm bootstrapped. I don't want to have that argument. I want to have the impact of all buildings are designed in Revit. I want to be in Revit. I don't want to have, spend a bunch of time spinning my wheels making some, export your data to here, and then, or use an open standard like IFC that no one actually uses. It's like, all projects are in Revit. I'm going to build in Revit.
IFC always boggles my mind. It's like, you have to be able to send it to something, and there's just nothing that could take like a mechanical IFC model and do anything with it.
Yeah, and edit it. Like, okay, I want to add a duct to this IFC. How do I do that? It's like, learn the JSON or whatever it's in. I don't even know.
I think both of us think that the platform risk the other way is that there's no platform outside of Revit that we can build on.
Yeah, so it does really help. I mean, the fact that I can have one code base that supports every building design is very helpful. Now, there are AutoCAD jobs still, but those are kind of seem to be going down and down and down, and Revit jobs are going up and up and up and up. Because I mean, Revit gets a lot of crap, but Revit is an amazing tool.
Yes. And they actually built out the MEP side enough that we can do something with it.
That, and I think that's one of the real staying powers of Revit, is that it's cross functionality. So it's MEP, it's structural, it's architectural, everyone can design in it. And I don't see another software being able to do that.
Have you tried Duct Design, any of the other BIM packages?
No, I haven't even opened any of the other BIM
haven't even bothered.
Yeah. I mean, if somebody brought me projects that said, hey, I need this and whatever other BIM softwares there are, I would consider it. But I know not a single person has said, well, what about this BIM software?
Yeah. Yeah. And when we're talking to people, it's always like, okay, we're in AutoCAD, we're in Revit. No one else is ever talking about any other thing. So
that's right.
As much as there are other places that architects work, I think if they're not in Revit, essentially they export down to AutoCAD and then they finish the project out there.
Yeah. It always ends up in, what it really always ends up as is a PDF. So that I think is another reason that startups will say, okay, we're going to be PDF based, because it always ends up as a PDF. And then you've got hey, is the Revit model actually going to be delivered to the contractor? Maybe not. Maybe the project's in Revit, but maybe the person who needs the tool just has a PDF, which is a shame.
Yeah. So you're building this software for other people. How should other engineers think about doing this sort of automation for their workflows?
I think so. There's a lot of companies out there that want to bring, build tools in-house. And I think that's typically a bad idea. And the reason I think that is because I get contacted by a lot of these engineering firms that say, we had this guy, he builds a bunch of tools and then he left, and now we don't know how to maintain him. We don't know how to bring him into the next version of Revit. Can you support this? And I always say, you you would not want to pay me to do that. I mean, it's very expensive, and these tools just end up getting abandoned, the ones that get built in house. So, it's typically, I think, a bad idea to try to build your own software in house. There's just so much maintenance required. Revit updates every year. Um, it takes a lot. That being said, there are what I would say if I were a consulting engineering firm is I would use a Ripple, a Design Master, anything that has, a commercially available automation tools, use that and then build around it what it does. Because, like, diffuser layouts, let's say, I only lay out certain types of diffusers. Some engineers like different other types of diffusers. So I only lay out overhead diffusers and ceiling grids and open spaces. Some engineers like sidewall diffusers. It's like, okay, you could use my tool for the overhead stuff, and then you could build your own automated tool for the sidewall stuff. So it could save you some time of, fill in the gaps around that. That being said, I have another contract with Price Industries in place to build sidewall layouts. So,
So you're working on that.
that'll be done. Yeah, that'll be done soon.
Yeah. But maintenance is really the bigger issue on those building
Yeah.
it in house.
Maintenance, and it can't just be one person that knows the code base, because that person's going to leave. So now you've got to have multiple people that know the code base. And so now you've got a lot of salary tied up in knowing a code base. Is it providing you that much value? It is a question. And then if consulting is a pretty low margin business, so you've got a lot of consultants out there that are trying to make the profit necessary to support developers who are extremely expensive. So it's generally, I think, a bad idea.
Yeah. So a lot of times, in terms of the buying side, AEC gets labeled kind of as slow to adopt technology.
Yeah.
Do you think that's fair?
I think that's fair. Yes, I do think that's fair overall as an industry. But if you look at like the individual companies, I always go back to, that famous McKinsey productivity curve of the, construction productivity has been flat, and every, design is no more productive. Construction is no more productive. Nothing is more productive. So I always kind of think, and it's been lightweight since like the 70s, so we built buildings just as productively in the 70s as we do today. So anytime somebody's trying to sell software or technology and saying, oh, this, over the last 50 years, you kind of have to say, okay, why has productivity not gone up? Like, if all of these tools are so amazing, why are we still just as unproductive as we were, or as productive as we were in the 1970s? So, it's hard to hold an old crotchety engineer to blame when he says, I'm not learning that, I'm not doing that, because he's probably just as productive as somebody with all the new tools.
I think part of the productivity gets eaten up in more intense requirements.
Yes.
For the design. Like previously on the electrical side, like a lighting calculation, you could do a quick room cavity ratio, just kind of do an average, and that's good enough. And now, as it got more sophisticated and we could do more intense calculations, now it's like, okay, let's do point by point calculations inside. Like, okay, we've just raised the bar and asked people to do more, and the building's still kind of going to be basically the same at the end.
Right. Same amount of lights. Yeah. Although, yeah. Yeah, I mean, and look at like the code books. The 1970, the code book was this big, and then, it gets bigger and bigger and bigger and bigger. I'd love to see a graph of, number of pages in the codes over time. I'm sure it's so yeah, that might be a cause of the productivity, but I mean, I think as a skeptic, you have to be willing to look back at all the technology we've done over the 50 years and say, this hasn't helped. None of this has helped. But I think we're at a turning point now where I think BIM is really allowing, like I said, all of this data can just be pulled in, and if you just automate task by task, it's really going to be a game changer. I think, although that's what people have been saying for the past 50 years.
Yeah. So that said, what should people be focusing on right now? What should they be thinking about with AI and BIM?
I mean, I would definitely say you need to be automating your processes, and you need to be figuring out what you're going to do when there's no more billable hours. You can't have a billable hour based business for much longer. It's just not gonna. It's not gonna stand.
Do you think that's going to go away?
Absolutely, yeah. I don't think any owner is gonna pay for billable hours anymore. They'll pay for output, but I don't think they're gonna pay for billable hours. It just doesn't make any sense. And it doesn't make any sense for engineering firms to continue to push billable hours because it's going to be like a rug pull. All of a sudden, owners just aren't going to stand for it.
Yeah.
So that would be, if I were a leader of an MEP consulting firm, that would be my top of mind. That's what would be keeping me up at night.
Yeah. All right. Any other final thoughts?
No. Ripple is a free plugin. Get out there and try it. So we're paid by the manufacturers. They want to be in as many projects as they can. They want to be the easiest to use. So the tool is free to consultants. So get in there and
Where do they find that?
RippleEngineeringSoftware.com. So you can reach
All right.
out to me. I'm Kevin.Lawson at RippleEngineeringSoftware.com, or find me on LinkedIn.
Very good. Hey, thanks for taking the time to sit down and talk.
All right. Thanks a lot.
All right.
All right. Bye-bye.